Actigraphy Work Group meeting. My name is Tanya Williams, and I am CPR&D Senior Project Manager. This is our agenda for today's meeting. We will have a presentation by Ruby Abrams on the feature extraction summary and next steps, followed by validation considerations and next steps and closing remarks by Colin. Colin, are there any additional opening remarks before we proceed with today's call? And before I ask you that, apologies. Just want to make sure that there are no objections to us recording today's meeting. Okay, let's record it, and I'll share back the screen and give us a second to do so. Okay, Colin, any additional opening remarks?
No, I think that I think we're good. I think that we'll go ahead, and I think that's important in this meeting is just to give us feedback on the analysis and feature extraction, and then I think that this will sort of it will bridge into the next discussions. That I think the first step of many will be the what's some discussions. I think we need to continue to come back to this and based on the feedback we had heard from the group around clinical validation and device concerns and whatnot. But I pass this to Ruby to continue the initial discussion of the main topic today.
Thank you, Colin. And Ruby, you have control now to share your screen.
Sure thing. Thank you very much. Let me make sure. Okay, so today I would like to go over all the features that have been extracted. This is an overview here. The main construct we're interested in are bout characteristics. So some of the characteristics we're interested in are the number and duration, or distribution of time and number over all days, also per hour, and then also per day. And then I'll go over the types of features that we're actually extracting per bout. These are summarized as statistics of 4 main features, which are stride duration, stride length, stride velocity, and cadence. And I'll explain this asterisk over here where we're using proxies. And then we aggregate these features per hour, per day, and I will finish off with an example of longitudinal trends. So to start this off, I want to start with an example of a patient's data here that happened during July. We have plotted here the 3-axis accelerometer and its magnitude on the top panel. And then on the bottom, we take that magnitude, we subtract 1 unit of gravity, we obtain the NMO, that's what it is defined as. And on top, we have developed a bout detection algorithm, which is highlighted as an orange indicator function telling you if it's a value of 1, it's classified as a bout, and if it's not a bout. And this is our main construct that we're interested in looking at. And for the first few characteristics, we'll be looking at like the distribution of times, duration, and the number of them per different units of time. So for example, we can take the duration of the widths and do a histogram distribution over all 6 days. And we see that like primarily most bouts are pretty short. The shortest bout recorded are 2.6 seconds. And the longest one that's been recorded is nearly 2,500 seconds. And on the right here, we have a bar chart showing the number of bouts that happen per day. And I'll also point out that there were less than 100 that happened in the last 2 days of this individual's behavior. This is an example of the number of bouts, the distribution of the number of bouts over 6 days. So we can see, say, like, for example, the median line suggests that this individual is more active, or has more bouts during the earlier hours of the day. We can see some low activity durations during the early hours. Yeah, so just to give like an example of individual behavior throughout the day. We can also look at the duration of these bouts throughout the day over 24 hours, the time distributions. Of course, this is very biased. We can't see much because we have these large outliers. This large outlier, which is about 45 minutes long. And we'll look at this example for how features are extracted and aggregates are extracted as well. For what follows, we'll be analyzing this longest bout, but this procedure is applied to all bouts. So on the top, we have a very noisy signal. We can't really see much. But what I'd like to point out is our step detection algorithm within this bout detection algorithm identifies 2,486 stationary points. And as a visual kind of confirmation of this, we can see all of these stride profiles that are extracted between stationary points of this longest bout superimposed in this bottom left image over here. So it's about 100 long, which is corresponding to the longest sample the longest bout detected within this the longest step detected within this bout. And we can see at a 30 hertz profile, it takes about 1 second to do one stride profile, one stride step. And I'd like to point out that this is about 964 out of nearly 2,000 that were detected. And we can also see like the first 3 minutes on the bottom right to kind of show that there is this waveform that repeats itself, that has 2 lobes, and also a visual confirmation that we are correctly estimating the stationary points between stride profiles. So with that, I would like to point out the clinically relevant features that we are extracting from these superposed stride profiles per bout. First, we look at the distribution of stride durations, just the width of these profiles. Second, we look at the range of acceleration, and we use this as a proxy for stride length, just because given the acceleration data that we have now, there are some issues with that gyroscopic or angular velocity data to compute stride length appropriately. So as a proxy, we're looking at the range of acceleration values per step. And then we'll also create this proxy, which is a proxy for stride velocity, which is going to be the ratio of the range of acceleration divided by the stride duration. So this will have units as gravity per second. And then lastly, we also compute the cadence, which is inversely proportional to the stride durations. And we'll have that as an example of in units of steps per minute. So with this, I see that there's a question so far.
Yeah, sorry, can you hear me?
Yes.
Thanks. It's a clarification question. What is on the negative side of the scale?
On the negative side of the scale here,
Yeah,
for the ENMO, so this was 1 unit of gravity removed. So even though this is a magnitude and a positive quantity, we are just looking at like the magnitude above the effect of gravity. So yeah, the negatives don't actually correspond to any physical. We can't have like negative magnitude, but it's just the fluctuation of force around 1 unit of gravity.
I see. Trying to understand what it means in terms of that stride itself. It seemed to be repeatedly happening, right? In all strides.
Right, right. So the sensor will pick up the gravity as well as any force exerted by the individual. And this is just like the fluctuation or the profile shape of each stride.
Thank you.
Absolutely. So the features that we're actually extracting are going to be the distributions that are extracted from each bout. So on the left here, we have those stride durations, the stride length proxies, the velocities proxies, and the cadence as well as distributions. And what we actually store are the characteristics, things like the mean, standard deviation, minimum, maximum, and a bunch of percentile ranges. This is a per bout feature, and so for all the statistical behavior of this bout is stored in this table of 40 features per bout. Next, we aggregate all these features per hour of day, which means that we have to look at the number of bouts that occur within each hour. And then we do a form of aggregation for all the bouts, all the statistical features for all those bouts in that hour. So we can see an example of the count of the number of bouts that are found per hour for, say, the stride duration count. The 40 features that were previously listed on the previous slide are now the column headers. And what we're extracting here are basic statistics per hour of those features. Things like the number of those features, the average, the standard deviation, the minimum, the median, and the maximum. Because we do expect like fewer bouts per hour than, say, per day. So with this, we have our 6 characteristics and 40 features that give us about 240 features per hour. And just in this table alone, we have 5,760 features. This is an example of the distribution of 95th percentile stride velocity per hour. So for all the bouts per hour of day, we can see the distributions of this particular centile stride velocity, defined as the range of acceleration divided by the stride duration. And with errors, we can see that there's like large maximum and low minimum. But what I'd like to point out is that the median is a rather stable signal and might be another way to aggregate over hours per day. Now, for aggregating features on a daily basis, we do a similar thing. We look at all the bouts that occurred on a particular day, and we expect to see way more bouts per day in a count. So we'll list up all the features that we were interested in per bout as columns. And then we'll also extract out some statistical characteristics of those features per day. So for the stride duration count, we can look at the number, the average, the standard deviation, minimum, maximum, and percentile ranges per day. And so with this, I wanted to give an example of the distribution of 95th percentile stride velocities per day. Here we have like the percentiles and the minimum and maximums that are displayed over time. And I'd like to point out that the median of this one in red is a relatively stable signal. So for aggregating some features over the entire duration of all the visits that participant week, we might want to also take like statistics over these points. And as a final example of longitudinal feature trends, we took the median value of the 95th stride percentile. So, sorry, going to go back here. We took the median value of the 95th stride velocity here, and we plotted it in blue at the top. And then for the orange here, we were looking at the average value and the median over multiple days. And at the bottom, we took the 5th percentile. And with this, we plotted all the features extracted per participant visit in the months since their first visit. So you can see the distribution of times. And this is for the left side. The same analysis was done for the right side. And just applying a Spearman rank correlation coefficient for all three of these curves, we can find moderate to strong negative correlation with significant p-values. So yeah, with that, we have a couple of considerations. The first being that we are extracting statistical characteristics and aggregating over those as potential digital biomarkers. So that's just something to consider when for the complexity of the interpretation, I guess. We can also verify how well the bout detection works by comparing the left and right side bouts per visit to give a little bit more indication of specificity of the bout detection algorithm. Our step detection also has an embedded upper limit of 210 steps per minute. So this is considered kind of like a jog or a light run. So I am kind of embedding assumptions here. And these algorithms will require verification and validation moving forward. Few forms have been done, but I think more might be necessary. So our next steps are as follows. We have processed 75% of the patient data, and the remaining is in progress. For the next steps of longitudinal modeling, we will start with incorporating the ALS FRS scores and considering relevant covariates to capture disease progression over time. This might involve a linear mixed effects model or nonlinear mixed effects model. We'll also look at correlations of our aggregated features with the clinician-reported outcomes or self-reported scores. We might also try to look at the subset of features that have nicer properties, like less variability, or using lasso regression. And things to consider moving forward as well are the daily bout behavior per individual and over all individuals, as well as looking at the trends between right and left sides longitudinally. That might be indicative of bias or compensation. So with that, I will pass it to Colin to discuss the following. I'll stop sharing my screen and pass it to Tanya as well.
Thanks, Ruby. Thank you for that presentation. And I see that we have hands now. So open the floor up now for questions. I'm sorry. Rakesh?
Rakesh?
Yes.
Sorry, I was muted. Sorry. So Ruby, thank you for doing this. I asked a couple of questions last time. I just want to, go back to that slide where you define those features at the start, the definition of these terms. And I have a couple of follow-up questions. I just want to understand the terms better. You are calling stride length as Gs per second. We talked about it last time. But if you look at this range of acceleration, when you are looking at range of acceleration, the unit is still in acceleration, right? So
Yes.
yeah, here. So that unit, when you divide that by stride duration, it basically becomes something called jerk, right? It's basically the rate of change of acceleration. The moment we start calling it stride length, from the interpretation perspective, it becomes like you're looking at how far somebody's walking, and you don't have that information, which is okay. But I think from the interpretation perspective, we have to really think whether to call this stride length, or is it the rate of change that you have per stride of acceleration. And that's jerk, that's meter per second cube, right? So eventually that's what your unit is. And that's where it gets difficult for me to really understand and call it a velocity, which is the next measure, because velocity you always relate to how fast you're going with respect to how much you are traveling in terms of spatially. And that's just, it's just my comment. Like when we are using these terms, I mean, we have to really understand, like, and I'm not sure if I really interpret this correctly with these terms. So that is just a comment. I mean, if you want to, and we talked about it, I don't want to repeat the conversation. But this is something I was just thinking harder like last time, and then I just want to bring it up again one last time. And one last question is definition of bout. What is your definition of bout? If you said the shortest bout was 2.6 seconds, which if you think about, and this is only on one ankle, so that's how many steps do you have to call something about? Because you can take one step here and there, and is that about? And I just want to understand what your definition of step is. Minimum two steps, three steps, or two gate cycles, something like that, because it's very varied in the literature. Also, if you have consecutive bouts, if the difference between the two bouts is, let's just say, less 3 seconds, do you call combine them into one bout, or do you call them separate bouts? That's another thing to consider when you're defining a bout. So I just want to hear your thoughts on that.
Right. So we're leveraging physiological periodicity or close to periodicity. So the bout is actually done by a sliding Fourier transform window and looking for the dominant frequency within that window. We do have to impose some like physiological constraints that the frequencies we're looking at are within what is humanly feasible. So we're looking at a 0.3 hertz to a 3.5 hertz frequency range. And
Okay.
from that, people can walk very slowly to up to 210 steps per minute, which is a light jog or a run. And this is an issue because of the step detection that's applied afterwards, because we might actually have overcounting. I've seen issues in this algorithm that might double count peaks and incorrectly segment the signal. So the bout is defined as in terms of a localized energy of those sliding windows, and I create a threshold if the localized energy is positive. If there's any localized energy, it's considered a bout. Once we have that indicator function, I do impose a minimum duration of these bouts. So I did forget to put that into this presentation, but the original distribution of bouts that we're seeing over here are over all bouts, but the analysis that we're looking at are of all bouts that are a minimum of 10 seconds long. And so that 2.6 seconds that you're asking about come down to two parameters of the bout detection algorithm, which are the window length and the hop factor. And so
Okay. So there's no physical constraints like number of steps, number of gate cycles, anything like that for definition of bout. It is purely based on the signal properties of the spectral components of the signal.
yes,
Okay.
and yes.
Okay. Okay.
Do we need to come back to that? I mean, I know that there's the consensus in the field. Is this something we need to come back and discuss more in detail with the group? I mean, I just want to make sure that we're all on the same page, because
I
obviously
I
we've got
do
a lot of
believe
people.
that
on
I
the
do
conversation that have done different methodologies, but, you know, making sure that everybody feels comfortable with those definitions is probably a very important point for us to
It also goes
come
to
to
the
consensus on.
it goes to the interpretation of what's meaningful and everything, and all of these are going to be very difficult to interpret that, right? But if you tell like, okay, bout of 3 steps, I'm just making it up, I'm not defining it, but just let's bout of 3 steps is something that is meaningful, or a definition that goes with interpretation. So that's why I do believe that we can actually brainstorm that part.
Christine?
Yeah, I kind of want to echo what Rakesh are saying, like, because the stride and bout, especially in the case of walking, are quite established sort of concept in the field of gait, right? And I think that um, if you using those words, then people already think about what they would like. Anyone who study gait would be thinking about along that line, which is what you observe the behavior from Rakesh. If what we're doing here cannot be mapped onto those definitions, I think we probably want to use terminology that avoid that confusion, that people insist that you have to link to those concepts. I think that what you came up with here are very, very interesting and could be very useful in terms of measuring disease progression and stuff like that. But I'm a little concerned that if you are calling them with the terminology that there has been a somewhat a consensus in this space, then you're gonna be criticized for the you're not really capturing the same thing. So you might as well better off to call it a different term or something to kind of avoid that confusion, right? Because like bout, there's like a ton of discussion around the work with mobilized D, for example, that how do you define about what qualify bout if you have somebody walking for 10 steps and stopped for 1 second and then continue again, is that 2 bouts, is that one continuing bout? So there's a lot of discussion around that thing, around that concept. So that's where I was really kind of wrapping my head around the use of bout in this presentation. It seems to be using the bout for something very different. I still don't quite understand what it is for what it's worth.
There's just one comment. I think what you're doing is, because you have only accelerometer data, so there's only few things you can do with this. That part is, I appreciate that. And one thing is, bout duration is really, really critical, and you can see that here. You can calculate that. I mean, also, so the definition of bout, once you tweak that, there is a lot of information here. Like cadence is fine. You can relate. You can get steps, cadence, and bout duration. Only these 3 measures themselves actually give you a lot of information just from accelerometer data. And looking at the distribution of daily, what you're planning to do is really critical too, because what we have observed is a lot of these individuals with ALS actually walk very small short bouts, right? And that's where the definition, once we agree to that, you'll see a lot of distribution at like a shorter lengths, and very it tapers down as you go, and as the bout duration increases, very few bouts. And when you are trying to do the reliability analysis in future, you will see every bout has a different length. So you really need to understand how many bouts are really important for us to give us those meaningful, stable measurement properties. And that's why these definitions, defining them earlier is actually worth the effort, because then we're going to aggregate these further and further and further. So that's why I'm just asking these questions again. I don't so I just want to understand that better. But thank you.
Thank you for your guys' insight.
And backing up, I mean, would it help? I mean, Ruby, do you think it would be helpful to discuss more some of the assumptions and definitions and what you're doing the analysis, so to get some other consensus from the group? Because I think what I'm hearing is that there's questions about methodology, which obviously we're going to have to come to at some point in a regulatory submission. So getting some additional feedback from people, I mean, and making sure that we're consistent with some of the discussions that we've had in like with Fernando's group, and obviously, you know, Christina Rakesh and you know, Derek and others, just to see like, you know, what can we learn from some of the definitions and experience there. The concept that you mentioned about short durations of activity is an important one. You know, I think in considering, you know, because we went through the discussions around peak and, you know, time and you know, duration, I guess is probably the better term. Duration and then peak, you know, depending on how you chop that up is it could be significantly different perspectives on how one would interpret, you know, the results. So thoughts there? I mean, would that be helpful for the group? There's lots of other people that can feel free to comment. Fernando, do you have any thoughts? I don't see Derek on.
I definitely think that the conversation that we're having and coming to a consensus on the concepts and the terms that we're using makes complete sense. I don't know if it means, you know, having additional breakout meetings with folks who have been steeped in that is the best path forward.
Yeah. I think that would be, I think, good. We can take that as an action item. And also relate that back to the technology, right? Because the technology and the sensitivity and specificity are going to be important when we think of that. And ultimately, if we can put Christine and Rakesh on the hot seat for that. Okay.
We certainly would love to help and maybe, you know, kind of share. I think Rakesh already shared some, and I think that we might have some data sets that could help to map what you're doing here to some physiological sort of relevant gait definition.
Yeah.
I don't know, Rakesh discussed that or not, but.
Okay. I mean, I think that bleeds a bit into the next conversation. One of the comments that came up on the last, I think it was the last working group, was the need to look at validation more closely, both from a device perspective and then a clinical step. I think Michelle was, you know, some of the comments that she brought up were related to that, and we were talking about like what elements we would need to produce together. Fernando had mentioned that they did have some diaries on some of the individuals that were doing the act graphs, and so like, you know, annotating, you know, when they were doing specific things. Obviously, the adherence and compliance would be, you know, a factor in that. I mean, nothing's going to be perfect, but if we expect perfect, we probably won't move anything forward. But I think our teams are looking at that right now with Fernando. I think we're talking about the device characteristics. Tightening up the definitions for the group is going to be really important in this. And if, you know, some of the validation steps that you all are mentioning, if you have data that we could look at from that perspective, it would be really helpful, I think. Because I think that validation part is going to be essential to the submission part of this. Yeah. I mean, I think if I'm missing, I know others have been in the same conversations about this. Am I missing anything else that we talked about for the validation steps? We were planning to bring those to the working group to walk through and in front of like Michelle and others at the agency, just to make sure, you know, are we missing anything? You know, what additional information might I need to support that part? Okay. Any other comments about that?
I would say that, yeah, building off of what Rakesh and Christine have been saying, that construct validity of the bouts that we're looking for, relating to get that validity, to get that confidence, we might need to relate it to previous definitions of bouts.
I think set up an offline conversation with some of the people that have been researching in the space, and let's really compare our notes. And then, I think the next meeting that we also have, I think Rakesh, you said you would be kind enough to start sharing some of the technical, steps and information that was requested. FDA should be back then, I think getting in front of this and then, getting their visibility to this will be important. Then we'll have a plan for the biodefinition steps and things like that we can draw a consensus from. And then I think our team is looking at with Fernando's help is looking at some of the diaries. And then I think, Christine, I think you mentioned Derek was doing some things with video. I think these things will tie some of the conversations together for the validation pieces. And I think, Fernando, I think you said that you'd done some. I mean, I think we're also going to be looking at the recorded information. I mean, the patient, when the patients are doing it in front of the videos themselves, so that they're mirroring the behaviors. I mean, personally, I'm right now, I feel we're doing a little bit of a fishing to see, okay, like, is this going to be sufficient, and where are gaps, to find out, like, if there are holes we need to prospectively fill or not. And not knowing that. And I appreciate everybody's thoughtfulness as we think through these steps.
Yeah, it's been a fantastic process to see what Ruby's been able to pull together. And as we kind of advance, it's I guess uncovering useful questions, and then that's forcing us to think about what we have that might actually be patches versus what we need to build. In terms of data. So we're certainly going to be able to contribute data that might be patches, right? Like you said, those diaries and the prescribed movements. But where that's not going to be enough, we're excited to work with everybody here to build the bridging data sets.
Yeah. Well, I mean, I think we've all talked about this, is that this isn't a one and done. I mean, I think this is going to be, something that we continue to grow and learn and adapt from. I mean, I think we'll have an early win, and then it will continue to get tighter and more effective as we learn more about what questions we need to fill. Okay. Are there any? I know we're have a few minutes left. Any other comments or questions? I think some of us are going to try to meet at the MND meeting. Others are welcome to join, where we ponder life's mysteries and try to work on some of these other comments. Anything else that we need to discuss today? Okay. We'll set up follow-up discussion points in the meetings. I think some of this we'll probably talk to at MND, and then we'll have a game plan on how to move forward. I think Rakesh is going to present at the next discussion about the technical things. I think once we debrief from the MND discussions, then we can sort of vet this with the agency about what the approach looks like, get some feedback on that, and then we can move on to those next steps. Sound good? Okay. Thank you so much, everyone.
Thank you, everyone.
Thank you, everyone.
Safe travels.
Thank you.